Hi, this is Amy Lewis, Cisco Marketing, and we're here today for another episode of Engineers Unplugged. We're talking IPv6 with Tom and Damian, and there's so much awesome to handle. I'm going to get off fast so that they can take it away.
Hey Tom, how are you doing, man? So we're here talking about IPv6. Tell me more.
Well, I'm sure you probably heard of the Internet of Everything. We've got a lot of machines now that are getting connected to the internet. You know, washing machines, Xboxes, TVs, DVD players. They all need to have some kind of connectivity to all the services that are available. The problem is there's not enough address space for that to happen. So similar to what happens whenever we run out of area codes for phone numbers, we have to create more space. Except because we're really bad at math, when we created IPv4 back in the 70s, we didn't plan that far ahead. Thankfully, though, we did come up with an idea that would allow us to have more address space in the future. And the Internet of Everything, when you're talking about having devices talking to each other and sending data back and forth without human interaction, we want to make sure that those devices can communicate one-to-one without any kind of intermediary translations like NAT. When we look at IPv4, there's a small amount of address space, and I'd like to demonstrate that for just a second.
One quick question. So my question is, you were talking about, everything talking to everything, right? So, one of the main reasons why I have a private network in my home, as an example, where, all of my electronic devices are on the network, it's there, but I also have a firewall, there at the router. So if everything can talk to everything, where's the firewall set?
So NAT firewalls that we've come up with recently are actually really, really bad things because NAT firewalls break end-to-end connectivity. Do you use Skype?
Yes.
Do you know why Skype is such a popular protocol?
I do not.
Because it bores holes through firewalls. Because Skype actually has to require the use of something called a supernode. Supernodes are unnatted devices that are publicly reachable by the entire internet. So see, even the things that we use daily that we think are NAT enabled actually aren't. It's a whole bunch of tricks. The firewall in your case will actually be either closer to the end host or it will be a transparent firewall that sits between the host and the internet, and it's not blocking protocols and things like that like you would think of with NAT. It's actually just analyzing each independent traffic stream going in and out and allowing or denying them based on rules. Things are going to get more complicated, but it's going to be better in the long run because we can now have more control over what we want to do. Mm-hmm. So let's do a little bit of visualization with IPv6. So I talked about how we're really bad at math. Well, in the 70s, we had a calculation and we did 2 to the 32nd power to give us the number of IPv4 addresses that we have available. That's about 4.2 billion. This is what that looks like. $4.2 billion. With IPv6, we have 340 undecillion addresses. That's a number so big I had to Google to figure out how many zeros is in it. Let me show you what that looks like. That's 340 undecillion. If this 4.2 billion, if you could visualize it being the size of a golf ball, that's the size of the sun. If we run out of IPv6 addresses in my lifetime, I'll eat my phone.
And your phone will be small enough so it actually won't, taste that badly. All right, so how's the adoption rate of IPv6 coming along?
Currently, we're sitting at about 1% to 2%, and a lot of that has been through the efforts of companies like Cisco and Google and Facebook, where they went out on IPv6 Day in June and said, we're just going to turn it on, and we're going to see who connects. And thankfully, for the people who have been using services like Hurricane Electric or Sixus or things like that, we have native connectivity In some cases, it's tunneled. In some cases, it's native. So we can start utilizing those things. But to me, the adoption rate of IPv6 is not going to go up until the content providers start providing things that can only be reachable over IPv6. So we had problems back in the day when we wanted to get people on IPv4, and the way that the founders of the internet fixed that problem is they just shut off the old network control protocol. They went in and said, we're going to turn this off for a couple of hours. Adoption rates jumped. Then it was a day. Then it was a week. And then one day they said, we're just going to shut it off totally. So when the content providers start doing things like Netflix streaming on high def, but only over IPv6, then the people at home are going to want to have IPv6 so they can watch the Friday the 13th Part 50 in high def Netflix streaming. And that's when adoption rates are really going to skyrocket.
So once that happens, what happens to all of my existing IPv4 devices? Let's say like my TV that's on the wireless network.
So that's the beauty of IPv4. It's never going to go away. It's a lot like Novell and DOS. You can never really get rid of it because so many things still need to use IPv4. The problem is that we've already run out of IPv4 addresses. If you try to get one from the providers right now, it's like trying to get blood out of a turnip. So we're never going to be able to shut off the IPv4 network. But what we're going to do is we're going to augment IPv4 with IPv6. So all your old stuff is still going to work, but you'll need new stuff to access IPv6 because a lot of the home networking devices, they don't really work so well on IPv6. And that's why companies like Cisco are working very hard to miniaturize that technology so that everybody can have it.
So IPv6 happens, I still have a whole bunch of IPv4 stuff at the house. Will my stuff be able to talk to it? I mean, will my router technically be smart enough to be able to do that translation, or are you just hosed? I mean, how does that work?
It's going to work at some point in the future. Right now, we're going to have to use some kind of intermediary device, like a load balancer. But in the future, by the time that your device runs out of warranty, the next device will be able to do both of those things.
So 6 months from now?
6 months from now is probably a pretty fair assessment. Okay. All right, I think that's all the time we've got, and here comes Amy.
Okay, so first I'd like all the Engineers Unplugged viewers to note, Tom said he's going to eat his phone. Question I have, does that make you smarter if you eat a smartphone?
No.
No? You all?
It actually works in the opposite way.
Well, okay, there's something we've all learned. The second thing, I think we all know what time it is. It's IPv6 unicorn time. How does this unicorn scale out? Go. It's unicorn time.
I was just asking, is it a race?
Yes, it's a race against time. What do you think? How did he do?
That looks like some sort of a thing that I don't really want to describe on camera.
It looks a little more like a duck with a horn, but horned ducks are awesome.
There you have it. Sure, unicorns are magical, but so are horned ducks. That's the quote of the day from Engineers Unplugged. So thanks a bunch, Tom and Damian. We'll see you next week on Engineers Unplugged.